Yeah, hi guys. I hope my audio and video both these two are fine. So in this lecture, we're going to see the one more basic electronics topic. So in the basic electronics series, we already saw what is a resistor, one video, and what is the original current and what is a conventional current and what is the difference between both these two and what about the directions also we define. And in the yesterday session, we saw one UGC net June 2023 cycle one question. That question is based upon the photodiode. Okay. And now in this session, we are going to discuss about one topic under the basic electronics series, that is a capacitor. Okay. So it is the foundation topics, guys. So that means the very basics that you should definitely know in order to move to the complete course of the UGC net electronics. Okay. So before going to the main content of this lecture, one announcement from my side is that if you guys are seriously preparing for the UGC NET December 2023 cycle, then I'm introducing one course, and this course is completely designed by myself, and it is called as a Intense Super 30 UGC NET Electronic Science course. That means only first 30 registered candidates will be selected for this course, and there is a 100% money back policy is there. That means whatever the topics I am covering in this course, if these topics are not up to JRF cutoff score, then definitely the money will be refunded. So I'm having the confident enough that whatever the topics I'm going to cover in this course, so that if you practice and prepare and remember well, then you can crack the JRF. Interested candidates may express your interest by WhatsApp to the number 8639439984. And in this course, what we're going to see is that basically these are the live online courses. I mean, live online classes will be there. Even though if you miss the any one live class, then you can watch the recorded video also. So total 90 plus hours video lectures will be there. Everything is online only. And the doubt clearing sessions also will be there. So in this one, whatever the doubts you for every 15 days, one doubt clearing session will be there. So you can clear your doubts, whatever you are having. And the topic wise notes also available. Previous year questions and the MCQs also will be solved. Okay. After completion of each and every one unit, and a unit wise test series also will be there. And the course fee is 20,000 rupees for the entire course. And coming to myself, I'm the Ashwani Kumar Gadige. So I'm having the YouTube that is named as Your Mentor, and I am the Unacademy ex-educator of UGS NET Electronic Science as well as the general paper also. So in this course, you are going to get both paper 1 as well as the paper 2. And so it is a part. So in my previous course, so many candidates got qualified the JRF, and now they are pursuing or complete their PhD in the ISC, IIT, and NIT Central University or the State University. Right? Okay, so now it is an introduction of my course, and now while coming to the present lecture, as I told that we're going to see about what topic? We're going to see about the capacitor. Okay. So how we discussed about the resistor in the first lecture of this YouTube channel, in this lecture we are going to discuss about the capacitor topic. Okay, fine. So basically, what is the capacitor? So usually all of you know that the capacitor is nothing but a battery. It's a battery type of thing, right? So capacitor is a battery type of thing, and which can able to charge. It can able to charge in the form of electrostatic field. Okay, it can able to charge the energy or else store the energy in the form of electrostatic fields. So basically, the what is the basic structure of the capacitor is that, so if you take any some plates as like this, so it is a, let's take it is a plate number 1 and it is a plate number 2, and if you connect the positive and negative polarity of both the two plates as like this, is a positive polarity and negative polarity. Now whatever the plate is connected to the positive polarity of the battery, that is positive, and obviously it is a negative. So now here the capacitance formula, that means if some kind of energy has to be stored, if some kind of energy has to be stored in between both these two plates, then definitely one condition has to be satisfied. What is that condition? If the D is the distance between both these two plates and A is the cross section area of these circular plates, usually these plates are circular, right? So circular means what is the area we can take? Area is equal to pi r square, right? Area is equal to pi r square, and where r represents the radius. And d, if the d is the distance between both the two plates, now what I can take is that if the distance between both the two plates is less than the area, cross section area of the plates. Okay, try to understand. If the distance between both the two plates is less than the cross section area of the plates, then some kind of capacitance will takes place, then only the storage will happens. Okay, so whenever the distance between the two plates is greater than the cross sectional area of the plates, then there will be no storage. Then it simply acts like a open circuited one. Okay, it simply acts like a open circuited one. I hope that you understood these points. Fine. And now the basic expression to the capacitance C can be taken as a C is equal to epsilon A divided by D. Okay, it is a basic formula. From this formula itself, we can identify what is the A, as we already discussed, and what is the D, also we discussed. And whatever the epsilon is there, this epsilon is called as a permittivity. Okay, and this epsilon can be taken as a epsilon naught into epsilon R. So permittivity changes for the different material. That means if you take one silicon will be having one permittivity, germanium will be having the other permittivity. So different materials will be having the different permittivities. And it is the epsilon R. So epsilon R is called as a relative permittivity. As if right now I told like silicon is having the one permittivity, something I told like that, right? So it comes in with respect to relative permittivity. That means silicon is having the one epsilon R, germanium is having the another epsilon R, carbon is having the another epsilon R. Okay, like that. Different materials are having the different relative permittivities. But while coming to the epsilon naught is nothing but a permittivity of the free space. Okay, epsilon r can be taken as a permittivity of the free space, and it is a constant. Okay, permittivity of the free space can be taken as constant. It is almost 8.8 into 10 to the power of minus 12 Faraday per meter. Okay, permittivity of the free space almost nearer to the 8.8 into 10 to the power of minus 12 Faraday per meter. Okay, so it is what we are going to take. And yeah, so now these are all the different parameters. So from this formula, what we can understand is that if the D is increasing, then the C decreases. Try to understand carefully. Here the parameters means whatever the concept I am telling you right now, this concept will be helpful to understand the passive transducers in the 10th unit of our UGC net. Okay, 10th unit of our UGC net. So if the distance between both the two plates is increasing, then the capacitance get decreases. Why? Because inversely proportional. If the area is increasing, then the capacitance also increases. If the relative permittivity is increasing, then also the capacitance will be increases. Okay, so it is the thing we can take. So if you want to change the capacitance, then you need to change any one of these three parameters, either epsilon or either area or else the distance between the two plates. Okay, fine. It is about the basic information regarding the capacitance. And now we will see about the one more angle of the capacitance. I mean, one more angle means what about the what we call reactance and all these things. So before going to the reactance, I will tell you one more thing. See guys, usually if I take the capacitance as like this, then let's take it as a C. So C is equal to, I already told you that C is equal to epsilon A divided by D. And now impedance of the capacitance ZC can be taken as a, what we can take is that minus J EXC. Okay, we can take as like this. impedance of the capacitance is equal to minus j xc. And xc is called as a reactance of the capacitance, that is 1 divided by omega c. Okay. So impedance of the capacitance and it is the reactance of the capacitance. Are you understanding my concept? Yeah, reactance. Now, if I substitute the reactance into this impedance, then ZC is equal to minus J divided by omega C. Usually, you may remember like this also, 1 divided by J omega C. Anything is fine. Why? Because J can be written as minus 1 by J and minus J can be written as 1 by J. Okay. So that's why here minus j divided by omega c you can write, or else 1 divided by j omega c also you can write. Anything is fine. So it is the impedance of the capacitance and it is the reactance of the capacitance. Okay. Now let's talk about one very important point here. Usually if you take the DC signals, for DC signals, what is the frequency? 0. And let's take the AC. AC, the frequency will varies from small frequency to high frequencies, right? So if I take the very high frequencies means in the ideal case, let's take F is equal to infinity. Of course, F will not be infinity practically, even I too agree, but I am telling in order to make you understand very easily, let's take the high frequency signals as a F is equal to infinity. Now, if I substitute F, I mean, usually omega is nothing but what? What I can write here is that omega is nothing, I mean, usually omega is a angular frequency. And if you want to convert this one into linear frequency, then omega can be written as a 2 pi into F. F is the linear frequency, omega is the angular frequency. Okay. So now, in the case of DC, if I substitute F is equal to 0, then what we will get? Angular frequency also will be 0. Yes or no? So whenever the angular frequency is 0, then what about your impedance of the capacitance? Infinity. Yes or no? Your impedance of the capacitance will be infinity. What it means? For the DC signals, where F is equal to 0, the impedance of the capacitance is infinity. And for the AC signals, for very high frequency signals, impedance of the capacitance will be 0. Why? Because F is equal to infinity means if you substitute here infinity, 1 divided by infinity is equal to 0. Okay. So from this one, what I wanted to tell you is that, see guys, carefully observe. For the DC signals, impedance of the capacitance is infinity means capacitors blocks the DC. Are you understanding? Capacitors blocks the DC. What actually the blocking of DC is that? Blocking of DC is nothing but a stores. Capacitor stores the DC. And while coming to this conclusion, for high frequency signals, capacitance impedance is 0 means capacitor freely allows the high frequency signals. Okay, capacitance freely allows the high frequency signal. So I hope that all of you understood both these 2 points. Very important points. If you are very much aware about these points means you will be very clear about the filters concept and all. Okay, so it is a one part of the capacitance. So up to now we discussed about the 3 parts, right? Sorry, 2 parts, right? So one is this one, normal formula of the capacitance. Okay, with respect to D, A and epsilon R. And another one is with respect to the impedance and reactance of the capacitance, correct? And coming to the another one, if I take the capacitance as like this, connected to some, let's take the DC, and it is a capacitance. Okay. Now let's take some amount of current is flowing through this one, I. Right? So now the voltage across the capacitor, let's take the VC. Now usually voltage across, I mean, as per the Ohm's law, what we will tell, voltage across any one device or else the voltage drop across any one device is nothing but the amount of current flowing through that device multiplied with impedance of the device, that is V is equal to I into Z. It is what? The Ohm's law, correct? Actually it is the Ohm's derived law, What's the Ohm's law is that R is equal to V by I is the Ohm's law. If you tell that V is equal to IR, I is equal to V by R, all these things comes under the Ohm's derived law. Okay, there is a difference is there. Okay, fine. That's not much important. So in the same way, so voltage across the capacitance, voltage drop across the capacitance is equal to current flowing through the capacitance into impedance of the capacitance. Okay, I hope that you guys understood, right? Okay, fine. Now that is equal to IC into, that is current flowing through the capacitance, into impedance of the capacitance. What I told, 1 divided by j omega c. Correct. Now VC is equal to IC divided by j omega c. Correct. Now VC is equal to minus j divided by omega c into IC. Okay. Now, if I take with respect to the magnitudes and angle, then finally I will get? VC is equal to 1 divided by omega c IC angle minus 90 degrees. Obviously, minus j is nothing but minus 90 degrees, right? So, finally, what's the conclusion I want to tell you is that after going through all these things, take one more color. Yeah. Voltage across the capacitance is equal to 1 divided by omega c IC angle minus 90 degrees. You need to stress one point here. What is that stressing point in this one? Now carefully understand. If IC is 0 degrees, then your VC will be 0 plus of minus 90 degrees. If your IC is 90 degrees, then your VC is equal to 90 minus 90, 0 degrees. If your IC is 180 degrees, then your voltage across the capacitance will be 180 minus 90, that is 90 degrees. If your IC is 270 degrees, then your VC will be 270 minus 90 degrees. I hope that you are understanding what I'm trying to tell. So from this thing, what you need to get the point is that in the case of capacitor, current is always leading the voltage. Are you understanding or not? In the case of capacitor, always current leads the voltage. How much phase angle it is leading? 90 degrees. The current is 90 degrees. The current is ahead, or else the current leading the voltage with 90 degrees. Okay. So usually you might be aware about the phasor diagrams and all, right? So if you ask me to draw the phasor diagram for this capacitor, see guys, if it is the 0 degree axis, and let's take it is the IC, okay, current across the capacitor. So IC is equal to 0 means what about the voltage? VC is minus 90. So it is minus 90 degrees. It is the voltage across the capacitance. So all of you understood? Okay. So if you are taking the IC at a minus 90 degrees, okay, IC at a minus 90 degrees, then what about your VC? Minus 90 minus 90 becomes is equal to minus 180. So this will be your VC. So in the case of capacitance, always the current is leading the voltage with 90 degrees. So all of you understand? Understood this concept? So in this class, we saw the total 3 different types of concepts regarding the capacitance. So what the first thing what we discussed is that, so initially it is a capacitor, and when the capacitance will take, I mean, basically capacitor is a passive type of device. Okay, it's a passive type of device, and you may tell that sir, why we are taking capacitance as a passive device? Why? Because passive device is nothing but it cannot able to deliver the energy, but capacitor will deliver the energy. See guys, So capacitors are delivering the energy. So why don't we take the capacitance as an active device? If you're getting that type of doubt, means the definition for the active device is that it has to deliver the energy to the next devices till t is equal to infinity. It is the original definition of the active devices. Okay. In the case of active devices, it has to deliver the energy to the circuit or the load till t is equal to infinity. But if your capacitor will deliver the energy up to t is equal to infinity, no, it will deliver up to certain time only. That's why we are perfectly calling this one as a passive device. And the voltage across, okay, V is equal to voltage across the capacitance, okay, or as the current across the capacitance, I is equal to C into dV by dt. Usually it is a general format, okay, or else Vc can be taken as 1 by C into integration of Ic into dt. These are also important expressions. Either I is equal, I mean, current flowing through the capacitance is equal to C, capacitance into rate of change of voltage across the capacitor, that is dVc by dt. Or else from this one, you can take the voltage across capacitor is equal to 1 divided by C integration of Ic into dt. Okay, we can take it as like this. So capacitance is all, capacitor also comes under the linear device. Okay. Usually, if you draw the graph between the voltage and current, then of course you will get the graph as like this. Little bit exponential will get, but the capacitor will comes under the linear device only. Okay. Inductor, capacitor, and resistor, all these things comes under the linear devices. Fine. And yeah, so I mean, what is the basic formula? C is equal to epsilon A by D. And how come the capacitance varies with respect to all these three parameters? That's what we saw. And coming to the second point here, so what about the impedance of the capacitance with respect to the reactance of the capacitance? So how both these two are related? And what about the ZC and all? And with respect to this one, we discussed about how come the capacitor blocks the DC and how come the capacitor freely allows the high frequency AC signals. And coming to the third part of this lecture, how to draw the phase diagram of the capacitor with respect to this equation, with respect to the normal basic Ohm's law. Okay, VC is equal to IC into ZC. So ZC, and so how we got this expression, and what about these phase angles, and how come the current is leading the voltage in the case of capacitor, and how to draw the phasor diagram of the capacitor. Okay, these are the things. Okay, so that's it for the present session. And before finishing my session, so as I already told you that Intense Super 30 course is going to start, guys, soon, and it is only for the first 30 candidates only. So if you are seriously preparing for the UGS Net Electronic Science, then you guys may prefer this one. And these are all the things you are going to get in this course. Okay. So video classes up to 90 hours, doubt clearing sessions, topic wise notes, PYQs, MCQs, and test series, everything you are going to get. So interested candidates may WhatsApp. Okay. So interested candidates may WhatsApp to this number so that I can send you the few more details. Thank you very much for watching this course and this lecture. So share this video link to your friends or colleagues who are preparing for the UGS Net Electronic Science. Okay, it will be very helpful to them, guys. Why? Because these are all the very basics, very much essential to understand the next concepts, or else to prepare your UGS Net Electronic Science in a smooth way. Right? Thank you very much and all the best, guys.